We are now going to do some applications with the stuff that we've learned. And I'm going to start out with this one here. And in this problem, we have a different way of designating direction. It's different than the bearings, and we haven't talked about this yet, but you do have one in the homework that is like this. So let me explain how this works first, and then we'll do this problem. Okay, so you have north, south, east, or I'm sorry, west, east. Got to get my directions right. So just got to remember we, right? And then you can get the direction there. Okay, so this is actually easier than the bearings. I find this a little bit easier, and it's kind of what maybe is very intuitive when you think of like a compass. So, for example, this is north, 57 degrees west. So, when you have north, it means you're measuring from the north, and you're measuring 57 degrees towards the west. Okay, that's what that would mean. Something like this would be south, 75 degrees. To the west, if that makes sense. So you could have, like on the one we have here, something like south 50 degrees east. So this would be measured from the south going towards the east 50 degrees, or north 50 degrees east. Okay, so that's how that works. So this is kind of pretty intuitive. So let's look at what we have here then. This says hikers travel north 57 degrees west for 8 miles and south 75 degrees west for 5 miles. How far are they from their starting point? So let me see if I can draw a picture here. So north 57 degrees west would be like moving this direction, 50, if this is north, and so this would be like 57 degrees, and that's towards the west, and this is like 8 miles, and then so they go like 8 miles, and then they travel in this case it's measured from the south 75 degrees. Okay, so here's kind of the south here, and this is like measured from the south 75 degrees. So this here is 75 degrees, and then they go, in this case they go 5 miles, right? And then what they're wanting to know is, what is the distance and the direction that they're going from the original starting point. Okay, and that's basically, this is adding this vector and that vector, adding the two vectors. So let's just call these two vectors v1 and v2. And what we're going to do is we're going to get the component form of these vectors. Okay, and so what we need here is I need to know what the angle is here in terms of theta. So for like this vector here, this would be 90 degrees plus 57 degrees. And then the magnitude is 8, right? So this would be 8 cosine. So 90 degrees plus 57 degrees would be 147 degrees. And then sine 147 degrees. Okay? And that would be that vector. So now I can write this, 8 cosine 147 degrees, 8 sine 147 degrees. And that is very hard to see. And then I'm going to get a component form here. So 8 cosine 147. I'm going to get it in terms of a decimal approximation. And so this is negative 6.70, and we'll just do it to the 10th place here. So I'm just going to cross that out, and then I'm going to do 8 sine of 147, and this is approximately 4.4. Okay, so that would be V1. So now V2, we can get the component form for this one. That's this vector, and so what we need here, if you think about it, we need from here down to there. Okay, so if this is 75, then here to here would actually be 15. So 180 plus 15 would make this 195 degrees is what that angle would be. So this angle, I should have wrote that there, is 147 degrees. So this is 195 degrees is what it would be. So I'm going to have, and the magnitude is 5. So 5 times cosine of 195 degrees sine 195 degrees. And, you know, I don't need to rewrite that every time. So I can just take 5 cosine 195. And that's a negative 4.8. And if I do sine of 195, I get negative 1.3. Okay, so those are the component forms. And so I'm going to take V1. So to find this vector, I just add the two component forms in V2. So that would be negative 6.7, 4.4. Oop, I'm going to run out of room here. So let me just do it here. V1 plus V2. This is going to be negative 6.7, 4.4, plus negative 4.8, negative 1.3. And so adding these together, I get negative 6.7 plus negative 4.8, and that's negative 11.5, and then adding these together, 4.4 minus 1.3 is 3.1. I could have done that in my head. Okay, so I get that there. So that's my resultant vector. That's this vector here. So I can find the magnitude of that. Maybe I could write it like this if I wanted to. So this would just be negative 11.5 squared plus 3.1 squared. And then I could get this in decimal form. So 11.5 squared plus 3.1 squared. And then I'm going to take the square root of that. And you see I get 11.9. So the distance here is 11.9. And then what I can do here is I can find the angle by using, so here's the vector, and so what I can do is I can use the tangent. So maybe I could draw another diagram here. So I would have this triangle like this, right? And this would be 11.5, this would be 3.1, and then I can find this theta by using tangent. So tangent of theta is equal to the opposite over the hypotenuse, and theta is going to be the inverse tangent of that. So tangent inverse of 3.1 over 11.5, and I get 15.1 degrees. And so that's this angle, and that, you know, that might be good enough, but if I want it in terms of one of these, I can do that, because you can see here what I got to do is I got to take 90 minus this. So 90 minus 15.1, that's like 74.9. So this would be measuring from the north and going 74.9 degrees, and then you're going towards the west. So this would be the direction you are from your starting point. Though this would be if you were standing at the starting point and going there. I guess if you wanted to know going here, you could do it, but I'm not going to worry about that. You get the idea. Okay? So, we have another one here. And on the homework, you have one like this, and it gives it to you in terms of bearings. Okay? But I've used these here just to give you some extra practice with this new way of doing directions. So maybe why don't you give this a try first? You can pause the video, give this a try, and then make sure you're paying attention to all this. You got wind and stuff, and so you got to remember last time what we did with some of that. So go ahead, give this a try, and then you can start the video back up and you can see how you did. Okay, so let's give this a try here. I'll try to make a nice big picture here. So a plane leaves here. Let's say this is the starting point. Or no, this isn't even it leaving. This is miles per hour. So let's do these two vectors. And since it's not position, I'm going to do them from the same point. So this is, it says it's, so we got south, and it's going towards the west, 35 degrees. So I have this angle, and that's 35 degrees. And the magnitude of this is 275 miles per hour. And then what you got is wind, and it says it's coming from south, this is south here, an S, south 50 degrees east. So if I do that, then you would have, and I'm going to make a dotted line here, because if you remember, so it would be like this. This is like 50 degrees. So if you remember, if it's coming from this direction, you would be going this way. The wind is coming from that direction. It's weird when you use this, because normally this is almost the sort of notation that you use for change in position, kind of like the hiker problem we just did. But let's go with it. We're going to go this, and it'll be 65. So it'll be a lot shorter, right? 65 degrees. Now what I need to know is I need to know these angles. So I got to know that angle. Okay, well I can know this because this angle is going to be, and that, boy, that looks like 65 degrees. I did not mean to do that. That should be miles per hour. There we go, 65 miles per hour. Okay, so let me say again here, you have this, and then these two, this should be 50 degrees here, right? That's 50 degrees. So this angle that you need here is 90 plus 50, which is 140 degrees. So that's one of the angles. And now I need this angle that goes from here to there. And so I can get that because I know this is 270, and so if I back up 35 degrees, I would get 235 degrees for that one. So let's do V for the velocity, and this is going to be 65 And then I'm going to have cosine of 140 degrees, sine of 140 degrees. And then we will do one for the wind, which is, sorry, this should be 275. 275. The wind is the 65, so 65, and, nope, I did it right. I just labeled these wrong. So the wind here would be cosine 140, sine 140 for wind, and then v for velocity of the plane, 275, and that's the angle is 235 degrees. So cosine 235 degrees, sine 235 degrees. Okay, so let's get the component form of these. So I have 65 times cosine of 140, and that's negative 49.8. We'll do it just to the nearest tenth, and then change this to a sine, and I get 41.8, positive 41.8. So that's this vector, and now this vector, 275, and I have times cosine of 235, and I get a negative 157.7, and now for sine. And this is a negative 225.3. Okay, and then we can add these two together. So I'll do it, we can do it over here. We'll do V plus W, and this is going to be negative 157.7, negative 225.3, plus cosine of sorry, negative 49.8 and 41.8. So let's do this. So I'm going to do, I got negative 157.7 plus negative 49.8, and I get negative 207.5, and then I have negative 225.3 plus 41.8, and here is negative 183.5. Okay, so basically what I'm doing here is, if I draw this here, I'm using the parallelogram rule now, right? And so I'm really getting this vector. I really got this vector right here is what I got. Okay, and so now let's find the magnitude and the direction. So the magnitude is easy. It's just the square root of negative 207.5 squared plus negative 183.5 squared. And so we got 207.5 squared plus 183.5 0.5 squared, and then I'm going to take the square root, and we see that the magnitude is 276.9, or it's 99, so it's actually, let me just say 0.9. It should have rounded up to 277.0, but we'll say that, miles per hour. Well, let me actually, this is like 99, so let's just say it's 277 miles per hour. It really is. So that's how many miles per hour it is. And now the direction. So we got this right angle here, and this is the so let's see here. It looks like this is the, boy, that I wonder if I did that right, because this looks like the y should be a lot smaller, and in my drawing it's not. So maybe my angles are not accurate. I'm going to guess that they're not accurate, and also this should be down more. So yeah, I'm thinking I did everything correct here. So, and this should be like 207. I'm going to ignore those signs. So 207.5. Okay. And so what I'm going to do is say that the tangent, and this is my theta, the tangent of theta is equal to the opposite, 183.5 over the adjacent, 207.5. And so I can get that this theta is inverse tangent of 183.5 divided by 207.5. Oh, I did the tangent of that. So let me do this again. Inverse tangent of 183.5 divided by 207.5. And I got like 41.5 degrees. 41.5 degrees. Now that's that. So if I wanted the angle that you would use to measure from x-axis counterclockwise, I could add 180, and I would get 221.5 degrees. Or you could do this type of direction, which would be awkward for this, or the bearings, or whatever. But you get the idea. So, in the homework I have two final problems that are really that involve systems of equations and solving for the component pieces, and they're real nice problems. But I think right now it's already so late in the day, and I've been working a long time on these videos, and they're also kind of challenging problems. I think for this time I'm going to not worry about those. So I'm going to get rid of those. I'll probably add two more applications that are more like this. So I got to go see what's available on there, and I'm going to switch those out. And I think that's a good plan. And we'll just stop here for now. And here, this is so simple as far as getting things in component form and using the component form to combine them. And what a great thing to carry away from this class. And I think oftentimes, because those other problems are thrown in there, some students maybe lose track of the value of what they just learned here. And so I think we'll just stop right there, and that would be a great place to stop. So I hope you enjoyed this section. Man, I'll tell you, I love this section. This is one of my favorite sections in all these applications. So I just think this is a pretty cool section, and I hope you do too. And we're going to, after this, just move on to parametric equations, and that's going to be our last section in the class. So, okay. So good luck on the homework.